another episode of interview series conducted by the Department of Chemistry, University of Colombo. My name is Krishan Garanthan. I'm a final year computational chemistry undergraduate student. Today, I will be interviewing Professor Matthew J. Allen. He is an American chemist, professor and chair, Department of Chemistry at Wayne State University, Detroit. Good evening,
Good afternoon.
Morning, Professor Allen.
It's morning here, afternoon there.
I'm sorry.
That's all right.
Thank you so much for allocating your valuable time to take part in this interview series. So, to start with Professor, can you give us a brief introduction about your childhood? What inspired you as a child?
Yeah, so as a child, I guess I was always really curious to see how things work, you know, taking things apart, putting them back together, and then kind of just, you know, playing with my brother and friends and stuff. You know, and then I was always fond of science, and yeah, just mostly like a curiosity for knowing how things work. I think was a big inspiration.
So what exactly inspired you to choose the field of chemistry?
So the field of chemistry specifically, I think, was a outstanding high school chemistry teacher that I had. So I liked all kinds of different science in high school, and yeah, I had a really passionate chemistry high school teacher, Mrs. Zemer, and yeah, she convinced me that that's what I wanted to do, at least for a major in college.
Okay. So most of the research are based on inorganic chemistry. So why inorganic chemistry?
You know, I think so. I did well in inorganic chemistry in college, and I had a really good research experience with inorganic chemistry in the lab of Jillian Buriak when I was an undergrad. And I think there's lots to learn there, and I think it's fascinating seeing how metals interact with ligands and things. And yeah, so I think inorganic chemistry, I think is very broad, and I like that aspect of it. So it gives me a chance to interact with inorganic chemists, organic chemists, biochemists, and it allows me to be sort of just an all-around chemist, and I like that aspect of thinking about different parts of science and sort of putting them together in different ways. I think inorganic chemistry gives me the opportunity to do that really well.
So can you give us a little bit of insight about your research in lanthanide chemistry?
Yeah, so we in my lab study the lanthanides. With F block, we recently started doing a little bit with uranium, so F block in general, but largely lanthanides. And so we do a lot of coordination chemistry, and so making new ligands to make the metals have different properties, and then studying those properties, and some of those properties are relevant to magnetic resonance imaging. Some of those properties are relevant to catalysis. Some of those properties we can take advantage of to do things like extract rare earths from waste products from other things. And then recently we've been adapting some of our chemistry over to uranium. And so one of the interesting things we've been getting into recently is looking at divalent lanthanides and how we can make ligands to study the properties of lanthanides in the +2 oxidation state, where normally they all prefer to be in the +3 oxidation state. So we've been finding some really, really interesting things there with respect to catalysis and MRI relevant properties.
Okay. So, Professor, can you explain what is asymmetric catalysis means? So give us a little bit of some insight about the new catalyst in organic synthesis.
Yeah, so asymmetric catalysis is catalysis that involves the making or breaking of a stereo center, and so it takes some special thought to put into the ligands to design the ways that they can interact with substrates to either make or break stereo centers selectively. We've been getting into, we can make a lanthanide with a ligand on it that forces it to absorb visible light and promotes an f electron to a d orbital. And then the f orbitals are these can become potent reducing agents in the presence of visible light. And so that's doing a lot of catalysis recently, not necessarily asymmetric for the photoredox, but definitely some interesting new mechanistic things to study.
A principal investigator of the research lab, which is the Allen Laboratory. Am I right?
Yes, that's correct.
So what are the responsibilities as a chief investigator of a research laboratory? And can you walk us through some of the ongoing research as well?
So yeah, I mean, the chief responsibilities, that there's a lot. So it's a lot of different things I have to do. So, you know, it's almost like running a small business, right? So you have to raise enough money to support the science. And so writing grant proposals is a lot of what I do. You know, helping to plan the research, mentoring students and postdoctoral researchers in the lab. So I spend a lot of time interacting with students, you know, daily. It's a little trickier now with the pandemic going on. We have a lot of phone and video calls, whereas before the pandemic, my office was across the hall from the lab and I could just walk across the hall and chat with people. Hopefully we'll be back there soon. But yeah, so sort of helping steer the research, applying for funding, you know, writing papers, sort of disseminating the research, talking about it to people. Those are sort of the main jobs of being the principal investigator. Recruiting people into the lab, so helping people in the lab get good jobs when they leave.
So Professor, in your opinion, what makes a good scientist? I mean, what are the qualities that a scientist should possess other than their curiosity and the passion for science?
Yeah, so I mean, I think the curiosity and passion for science is a minimum. I think the best scientists are very observant, so that, you know, you can find a little detail that, well, some people would just, you know, brush aside, and some people can turn that little detail into an entire thesis. So there's lots of really interesting science if you're paying attention, and it's hard to pay attention and know what's worth paying attention to if you don't read. And so outstanding scientists read a lot, primary literature especially, just to, it's hard to contribute to science if you don't know what science is out there already. And I think good scientists are patient, and they're also good communicators. You can discover the most profound thing in science that anyone's ever discovered, and if you can't share it effectively, then, you know, what's the point?
So you have been hiring people for the research field for a very long time. Mm-hmm. I mean, what do you choose as the qualities that a scientist should possess to carry himself in a research laboratory?
I mean, so when I'm thinking about students joining my lab, you know, I don't look, you know, we do lanthanide chemistry. I don't necessarily look for people with lanthanide experience. I look for people that are curious about science, right? So they've read papers and they have lots of questions to ask, and you know, that's, and I don't necessarily look for a 4.0, like the GPA doesn't really matter as much. I think someone that's motivated, that's an A- student, is going to be a much better scientist than a 4.0 student that's bored and doesn't really care about science or doesn't pay attention. So grades don't really matter as much as just sort of when I talk to people and interact with them, you know, how they talk about science, how much have they read, what do they understand, and what do they know they don't understand that they'd like to learn. So that's a big driver for sort of letting people into the lab.
Curiosity is the most driving force.
Curiosity, yeah, absolutely, and the sort of the passion to follow up on them. Yeah.
So there are so many students that are majoring in science, basically. Mm-hmm. But do you recommend a scientist as a career pathway to a person who is an undergraduate?
I think if someone's interested in science, I think science can be an outstanding career path. And so I guess the short answer is yes. And then the longer answer is there's lots of opportunity for scientists, not just in the university setting. There's lots of industrial and government jobs for scientists. I think the unemployment rate for scientists is lower than for the general public. So that's, I'm not sure about in Sri Lanka. In the US, that's the case. And so like there's opportunities there. One thing, especially for PhD scientists, you want to be able to be movable. If you're sort of stuck in one geographic area, you can find a job. It's oftentimes more difficult to find a position if you're limited geographically. If you're willing to move wherever, there's lots of jobs for PhDs.
So basically after, basically
no, go ahead. Yeah.
After PhD, what are the most students doing? Are they joined to research, private research, or this universities, or some? What are they normally do?
So it's a mix. I wouldn't say normally really applies to anybody. I mean, out of my lab, people have gone on directly to industry positions. They've done postdocs to industry. They've done postdocs to academic positions. I've got a former student that's working for the city of San Jose. Actually, she's a graduate of Colombo. She did her PhD with me. You know, and so there's just lots of different things. And so I've been chair of the department for 4.5 years. And when I started as chair, I made this new program, Chemistry and Food Fridays. So it would be, we'd get pizza for all the graduate students, and we'd invite an alum back to talk about their career and what they've done. And we've had alum come back and to talk about all kinds of different career paths that they've been on. And that's a chance for the graduate students in the department to network with these alumni, to hear about different careers, and to sort of get inspired to see what they might want to do with their degrees. And so there's just lots and lots of different things that PhD scientists do.
So now, what is your opinion about the advancement of scientific research in 2020 as the world is going through a serious pandemic? Like as you mentioned, COVID-19. I mean, what are the things that you think that need to be improved in order to face this type of catastrophic situations in the future?
Yeah, I mean, I'm hoping that I don't have to face too many more of these in my career, but I think that, you know, research is going to be slowed in 2020 for sure. I mean, a lot of places were shut down. Our labs were, like our university was shut down, including the research labs, for about 2 months. And then we did a lot of planning to ramp up. And now we're reopened for research, but it's at a reduced capacity. So somewhere between 30 and 50% capacity. And so things are moving, but they're moving at a much slower pace. And so I think 2020, 2021, it's probably going to be a slower look just for general advancement of science. I think that what we've learned from this is how to work socially distanced. But I think the most important thing here is that this has highlighted the need to communicate science. And I think using science to drive policy is really important. And I think that can't happen if scientists aren't willing to communicate and communicate well with everybody. And so, right, you can talk at a scientific conference with other scientists about your research, and that's a great skill to have, and that will help you get a job. But to help with a situation like the pandemic, you need to be able to talk to politicians, right? You need to be able to tell your siblings and your parents and grandparents what you're doing at a level that they can understand it and understand how important it is. And to the point that, you know, they and the politicians that they talk with or that scientists talk with can make informed decisions about how to, you know, handle situations. So I think communication, you know, in my mind at least, is sort of the most important thing that we need to work on collectively as scientists.
So as I mentioned above, I'm a computational chemistry major in the Department of Chemistry of University of Colombo. In your opinion, what is the role of a computational chemistry in the modern world of science?
Oh, I think it's critically important. I collaborate with computational chemists a lot with Professor Schlegel at Wayne State and some with others. But I think what computational chemistry brings to complement the experiments that we do is it gives us this richer understanding of how things are working mechanistically that would be difficult or impossible to otherwise wrap your head around and understand, and so it just increases the impactfulness of science, and I think it's really important. And especially I think moving forward, a lot of fields are moving into machine learning, AI, and I think that's going to be a big driver in a lot of fields, even fields where people aren't anticipating that that's going to be a big driver. I think being able to not just program, but understand the science and program is going to be a really critical skill in the future. You have a whole major on computational chemistry, or you're just doing some computational chemistry?
I'm a computational chemistry major, Professor.
Nice.
Nice. So now we have come to the end of our interview session. Finally, would you like to add something up, Professor?
Yeah, I think anybody that's interested in science, I think I'd encourage you to read a lot. Primary literature, talk about that with other people. And I just want to say, since this is here at the University of Colombo, that I've had the privilege in my career to interact with a lot of talented students from Sri Lanka and some from the University of Colombo, and I am very grateful for that experience. And the first PhD student out of my lab, Pravani Desanayake, was a graduate of Colombo, and she's now head of analytical chemistry at Gardner Gibson, a company in Florida. And Sashi, or Dr. Vipana Yakshi, she's probably the most well-known person to you, but she did her PhD in my lab, and she's a very, very talented scientist, and I've been very fortunate to work with a lot of talented people, including people from Colombo. So I'd encourage you to apply to Wayne State too. So there's a little plug at the end for Wayne State.
Thank you, Professor. It's great to hear that so many people known in US and as well as to you as personally.
Yeah.
So, thank you so much, Professor.
Thank you for the opportunity.
Yeah, thank you for joining with us and spending your valuable time sharing your ideas and thoughts with us. I think this interview has been a better chance to take a close-up look at a life of a scientist. What are the challenges in this field and how to overcome them? This will be a priceless motivation for our younger scientists. So, in order to conclude things, we have interviewed Professor Matt Talon. He is the professor and the chair, Department of Chemistry, Wayne State University. Thanks again, Professor.
Thank you.